Okay, our goal today is to solve absolute value equations.
Will this section be on the quiz, Mrs. Fox?
No,
Yeah, that's what I just told you guys. Okay, I just wanted to double check.
it will be on next week's though. To solve absolute value equations. All right, so if we are evaluating with absolute value bars, what does absolute value mean? Do we remember? Doesn't anyone remember? Everyone should have their masks pulled up over their nose. If I see noses in here, that is a referral. Okay, we don't wear our masks down here. That's not acceptable. Thank you. The absolute value is the distance away from 0. Okay, so our goal is going to be to solve absolute value equations, but these are expressions because they don't have an equal sign. Okay, so if we're simplifying expressions, because that's what we do with expressions, we get it down to a simple final number. Okay, so how far away is negative 26 from 0? 26. It's just talking about the distance, and the distance is always positive. So if you're dealing with the absolute value, what you do is you just make that number positive. Okay, how far away is 54 from 0? 54. How far away is negative 1.05 from 0? About 1.05, so we just make it positive. Okay, finish up those last two. Do number 4 and 5 on your own. For number 4, what'd you guys get? 13 sounds good to me. What about for number 5? 3 over 8 sounds good to me. Okay, so notice all of our answers there are positive. Okay, so the next thing what we're doing, this is what it's going to look like when we solve. We're going to have an x in our equation. We're going to have x inside those absolute value bars. And so what I'm going to ask you here is there is a number that is 24 away from 0. So what number, x, is 24 away from 0? But when you're at 0, you're on a number line. You could go two directions. You could go left 24 or you could go right 24. So you actually have two options. There are going to be two numbers that are 24 away from 0. So what could x be in this case? X equals negative 24 or x equals positive 24. Because you could plug in negative 24, take the absolute value and get 24, or negative 24 or positive 24 and get 24 as an answer. Okay? What would x be in number 2 then? Negative 1/2, or x could be positive 1/2. You could go to the left 1/2 or to the right 1/2 from 0 on the number line, and you'd be at those two numbers. Okay, now here's the tricky one. What number is negative 1 away from 0?
1.
1 is 1 away from 0. If I took the absolute value of 1, my answer will be 1. What number has a negative distance away from 0? Nothing. You can't find a negative distance. There's no such thing as a negative distance. You can't undo distance. Distance is distance. If you travel 1, you travel 1. Does that make sense? So in this case, there is no solution. There is nothing that we can plug in for x that's going to satisfy that. Okay, you cannot take an absolute value and come out as a negative number. Notice none of our answers were negative. They all were positive, right? So if you tell me that the answer is negative, I'm going to tell you there's no solution. All right. So absolute value is a number's distance away from 0. Oh, you guys can't even see what I'm writing. The symbol for absolute values are brackets that look like this. Okay. And there are always, well, I shouldn't say always. There are two numbers that have the same distance from 0. If it's a negative, there's none. And if it's 0, there's just 1. Because what number has a distance 0 away from 0? Just 0, right? 0 is the only number that has a distance 0 away. That's the only number that doesn't have an opposite because it's like that neutral. It's in between the positives and negatives. Okay. All right, so when we go to solve these, what we're going to do is we are going to get the brackets that look like this alone. That's going to be our first step. Our next step is to break into two scenarios. Once we have those two scenarios, we're going to solve each of those equations. And then the last thing that we are going to do is to check for extraneous solutions. And we're actually going to hold off on that for right now because I'm going to show you ones that don't have extraneous solutions first. So we're not going to get to step 4 quite yet. So if I put an example, let's just go over the examples on the back. That will be a little bit easier. So if you flip it over, we have some examples to do together. Now step 1 says to get the brackets by themselves. Are the brackets alone?
No.
Yeah, they are, because they're on one side of the equal sign and they're all by themselves over there. There's stuff inside of them. I don't really care what's inside of them. I just want to make sure there's nothing extra on the outsides of them. Does that make sense? So I don't want to have numbers out front or numbers behind it, okay? So that step 1 is done. And then it says to break it into two scenarios. So what I imagine is that these are like brick walls, okay? And they're super hard to tear down, but when you tear them down, they turn into these arrows because that's what breaks it into the two scenarios. And it took us so much hard work to break down those brick walls that we couldn't do anything on that left side of the equation. So we're just going to write that left side just the way it was, negative 5x. Now on the right side, we have all this energy. So on the right side, we're going to write 1 as the original and 1 as the opposite. Now these two equations look like stuff that you have worked at solving for weeks now. And years actually, because you've been doing these kind of equations in geometry last year and Algebra 1 your freshman year, and probably even in 8th grade. So you guys are pros at solving these kinds of equations. Right now, x is being multiplied by negative 5. So what we're going to do is we're going to go back to old school and just solve these like we know how to solve them. So you're going to divide both sides by negative 5. On the left side, we're left with just x. On the right side, 20 divided by negative 5 is going to be a negative 4. And on this one, we're going to have to divide both sides by negative 5. And we're going to get that x is positive 4. Now, your answers are not always going to be 4 and negative 4, or a number and its opposite. And you're going to see that in this next one. Okay? For right now, I told you we're going to hold off on checking for extraneous solutions. Okay? But if I did want to check this answer, what I would do is I would plug it back into the original. So I would have the absolute value of negative 5 times negative 4 is equal to 20. And what I would do is I would cover up that right side and I would say, How would I simplify this expression? Well, with an absolute value, I have to multiply on the inside first, so I'm going to get positive 20. What is the absolute value of positive 20? 20. So that side's 20 equals, on the right side, 20 just simplifies to 20, and it works. Okay. I hope everybody's writing these down on their notes, because I see a lot of people don't even have their pencils in their hands right now. Okay. We're going to do the same thing. We're going to plug in 4 this time. So the absolute value of negative 5 times positive 4 equals 20. Cover up the right side. We're going to simplify just the left side. Negative 5 times 4 is negative 20. But what's the absolute value of negative 20? 20. Equals, the right side we have to simplify. Oh, it's already simplified. It's 20. Does 20 equal 20? Yeah, so when we plugged in negative 4, it worked. When we plugged in 4, it worked. And we checked both of our solutions. Okay. Now, we're not going to keep checking them because I know by looking at these that they're not going to have extraneous solutions. And you're like, Mrs. Fox, you keep saying this word extraneous solutions, and I've never heard of that before, and I don't even know what it is. That's okay. We're going to get there in a little bit. Okay. So we're going to try these other ones, and we're not going to check them because, like I said, we're going to skip step 4 for right now, but that's how I am going to eventually start checking them. On this one, we go to step 1. It says get the absolute value bars alone. If you look at the left side, are the absolute value bars alone on that left side? They are, because nothing's outside of them. Okay? They're obviously going to have something on the inside of them, but they're like brick walls. This is like a brick house. Is the brick house by itself? Yeah. There might be some furniture in there and stuff, but that's okay. We want to make sure that there's nothing on the outside because you have to tear down those brick walls. So it's like all the shrubs and stuff on the outside. You got to get those away first before you can start tearing down those brick walls. Okay, so the first thing that we're going to do is we break it into our 2 scenarios because the absolute value bars are already by themselves. So those absolute value bars fall off into arrows. And it took so much hard work to tear those brick walls down that on the left side I have 2x minus 3 in both of my scenarios. But on the right side, I have one that is the original, 11, and one that is the opposite. And that's why it's important that we know how to find an opposite. So what is the opposite of 11? Negative 11. And you'll notice that that's been on every quiz so far, is finding an opposite of a number. And it is on your quiz again this week. Okay? All right, so the next thing it says to do, once we break it into 2 scenarios, is to solve each equation. You guys know how to solve the equation on the left, and you know how to solve the equation on the right. So what's the first thing we're going to do on this equation on the left? How do we solve it? Add 3 to both sides. What do I do next? Divide by 2. So I'm going to get x equals 7 as one of my solutions. This one, you're going to have the same steps to solve it, but you're dealing with a different number on that right side. So we get 2x equals negative 8. So our solutions here are x equals 7 or x equals negative 4. Okay. And as I said, over here, yes, you had 4 and negative 4, but that's not going to happen every time. Most of the time, you're going to have 2 completely different numbers, like we did in this case. Okay. Now the next one, the absolute value bars are not alone. So we actually have a step to do before we can even go to breaking it into the 2 scenarios. What's happening on the outside of those absolute value bars? It's multiplying by negative 4. So how do we undo multiplying? Division. So we're going to divide by negative 4 on both sides. The negative 4's cancel. I'm left with the absolute value bars is equal to positive 8. Okay. Now are the absolute value bars alone? Yeah, there's nothing else going on the outside of them. So that's where I break it into my two scenarios. On the left side, it took a lot of work to break those down. So I'm still going to have x plus 7 because I was too tired to do anything else. On the right side, though, I have one that is the original. What's my other one going to be? Negative 8, because it's going to be the opposite. I'm going to finish by solving both those equations. And my two solutions are x equals 1 or x equals negative 15. So far, so good? All right, so number 4, are the absolute value bars alone? No, so I'm going to have to get them alone. Now, that might look a little bit confusing. But if I were to have negative 6x plus 7, x is like the absolute value bars, equals 37, how would I solve that equation? You were going to subtract the 7 first and then do what? Then you divide by that negative 6, right? So you're going to think about this, even though you're looking at this big jumbled mess. If I had negative 6 times a variable plus 7, and I'm trying to get that variable alone, I would just start by subtracting the 7. And then I would divide by that negative 6 next. And those absolute value bars are now by itself. What do I do once I have my absolute value bars alone? Take down those walls. You break it up, they turn into those arrows. The left side stays the same in both situations. Oh, wait a minute. I don't have to go any further. Why don't I have to go any further here? It's a negative. I don't need to worry about any of this because can an absolute value, whatever I plug in here, can I take the absolute value of it and get a negative number? 100% no. No solution. So as soon as you have absolute value bars set equal to a negative number, you cannot do it because no matter what this number on the inside is going to turn out to be, you will never take an absolute value and get a negative number. So from there, you can just write no solution. Because that's a negative. Once you get these absolute value bars by themselves, you can say, okay, break it up into your two scenarios, but you didn't have to because it was set equal to a negative number. And an absolute value will never be a negative. Okay. Let's try the next one. We're going to have to kind of do those first same couple steps to start. So we have to get the absolute value bars alone. What are we going to do first? Subtract 10 on both sides. What comes next? Divide by 6 on both sides. I think that's 15. Okay. Am I done now? Do I say no solution this time? No, because it's not set equal to a negative number. So what do I do next?
You turn down the walls.
Tear down those walls and break it into your two scenarios. The left side's going to be 4x minus 7 on both sides. And the right side, what are my options for the right side?
We need 15 and negative.
15 and negative 15. Very good. All right, then I go and I solve both of those. Now these are equations that I've been doing for so long that I know how to solve these ones. What's 22 divided by 4? Can you do it? No, so you just have to reduce the fraction. Does 22 over 4 reduce? They're both even, so 2 has to go into both of them. So if I divide the top one in half, I'm going to get 11. If I divide the bottom one in half, I'm going to get 2. Then try that one. Does 11 halves reduce? No. So that's it, the end. There's one of your solutions. Or, we have to finish the other one though. Negative 8 over 4, negative 2. So there you go. Last one. What am I going to do in this last one? What's my first step going to be? Subtract the 50, because we have to get the absolute value bars alone. We get the absolute value of x plus 6 is equal to negative 35. What'd you say? No solution. The absolute value bars are set equal to a negative number. So yes, no solution. You don't have to go any further. Very good. You're done on that one. I like those ones. They make them a lot easier. Right? Because if you realize no solution, that's a lot less work than having to go and break them down. Okay, so now let's turn the page and we're going to talk about extraneous solutions. So the goal on this set of notes is to solve absolute value equations and check for extraneous solutions. When you are solving absolute value equations, you could have 0 solutions, where we would just say no solution. You could have 1 solution, or you could have 2 solutions. Okay. So it says sometimes you can get solutions that are extraneous, which are not solutions. Okay, and in order to know if they are a solution or not, you must check your answers to see. To check your answers, you must substitute or plug in your solution into the original equation. So we did it on one of our questions on the page before this, but we're going to do it another time. This one, it tells us the answers, that they solved this, and the answers they got were 12 and 3. So they got x equals 12 or x equals 3. And so we have to plug them back in to actually check them. And we plug them back in, we plug them back into the original. That's why it's important that you know how to simplify expressions, because that's what we're doing here. So negative 3 times 2 times the x value, will go 12 first, minus 15, close the absolute value bar, is equal to negative 27. Okay. The other one that we're going to have to do is negative 3 times 2 times 3 minus 15, close that absolute value bar, is equal to negative 27. All right, so what we're going to do is we're going to cover up the right side. We're going to pretend there's no equal sign. We're going to look at this left side as an expression. If this is an expression, all I do is PEMDAS. So I'm going to look inside parentheses or brackets first, and I have to simplify what's going on in there. So the multiplication has to come before the subtraction. So because of that, I'm going to rewrite everything that's on this outside, because I know that's going to be there regardless. The multiplication will come first, so 2 times 12 is 24 minus 15. The 24 minus 15 is 9. Okay. Now we have to take care of those brackets. So these brackets, they're like brick walls. They're not like parentheses. Nothing can go through them. Okay. So we have to say, what is the absolute value of 9? Or how far away is 9 from 0? 9. And now what we can do is we can write these in regular parentheses. Okay, once you ask yourself that question, you can change those absolute value bars to parentheses. And what is negative 3 times 9? Since there's not a operation there, we have to assume multiplication because it's right next to the parentheses. So what's negative 3 times 9? Negative 27, right? So that's what I'm going to get on the left side. I'm going to cover up the left side and simplify the right side to a final number. But wait a minute, the right side's already a final number. It's just negative 27. So let's just write that down here at the bottom. Is negative 27 equal to negative 27?
Yeah.
Okay, cool. So that means that x equals 12 is actually a solution. When we plugged it in, it worked. It's a solution. Now we have to do it with the 3 that we plugged in over on this one. So on this one, we cover up the right side. We cover up that equal sign. We have to simplify this expression. So what are we going to do first to simplify that expression? The multiplication inside those absolute value bars. So 2 times 3 is 6. Okay. Now we have to do the subtraction inside those brackets. So 6 minus 15, negative 9. Now I have to remove those brackets, but in order to remove those brackets, what do I have to ask? What does the absolute value mean? How close is it to 0? So how close or how far away is negative 9 from 0? 9. So we're going to write this in parentheses now. We can write it with just 9 because that's the answer to the absolute value of negative 9. Now what's negative 3 times 9? Negative 27. Simplify the right side. Oh wait, it's already simplified. Is negative 27 equal to negative 27? Mm-hmm. Yep. So I put a check mark. I put a check mark. And both of those answers were solutions. Okay. There are no extraneous solutions when absolute value equations have no extra variables outside the absolute value bars. So no need to check your answer when there's a variable, or no need to check your answer. When there is a variable outside your absolute value bars, that's when you need to check for extraneous solutions. So see how the only x was inside absolute value bars here? That's why both of our answers were actually solutions. Okay? See how there's an x on the inside and one over here on the other side? Yeah. We could have extraneous solutions. That means we might get an answer that when we plug it back in, it does not work. Okay? So, let me show you how to do this one. The absolute value bars on the left side are already alone. So what I'm going to do is I break this up into my two scenarios. It's just like last time where the left side stays 3x plus 5 equals and 3x plus 5 equals. Now the right side, you have one of them that stays the same. So one of them has to be 12x plus 8, but one of them has to be the opposite. So what is the opposite of 12x plus 8? Yes, because you're taking the opposite of this entire expression. You're going to negate the entire expression. That means that both of those terms are turning into negatives. Both terms, the sign has to change. Okay? So now we can solve both of these equations because they're equations like what we've seen for a long time. So I would probably subtract the 3x on both sides. I would subtract the 8 on both sides. I would divide by 9 on both sides. Negative 3 over 9 reduces because 3 goes into both of those numbers. 3 goes into the top once and it goes into the bottom 3 times. So x is negative 1/3. I gotta solve this one over here still. Add 12x on both sides. Remember, there's different ways you can go about doing this, depending on which side you move it to. Minus 5 on both sides. So x is negative 13 over 15. Okay, we are going to have to plug these back in because there's a chance that one of them doesn't work. And if that's the case, then we have to cross it out and say that it's an extraneous solution, meaning it's not a solution. So let's plug in negative 1/3 first. So we have 3 times negative 1/3 plus 5 is equal to 12 times negative 1/3 plus 8. Now what I would do in this case, because there's a fraction, is I would take advantage of my calculator. And I would say, okay, my right side's not there, but I have to simplify this left side. So let's figure out in my calculator what that center number is. Now, I know Mrs. Fox does not accept decimals, okay? But this is just checking my solution, which is a fraction. So as long as my solution was a fraction, I'm fine. Okay, so I'm going to go ahead and I'm going to type right in my calculator the inside and figure out what this is. So 3 times negative 1/3 divided by is just your fraction sign. Negative 1 divided by 3 plus 5. And the inside, oh wait, it's not even a decimal. Cool. It's the absolute value of 4. Okay, well the absolute value of 4, how far away is 4 from 0? 4. So 4 equals, okay, now I'm going to have to do the same thing to my right side. You can plug it in your calculator. 12 times negative 1/3 plus 8. I get 4. Does 4 equal 4? Yeah. Okay, so which solution then is a solution? Which one what did I plug in now? Negative 1 over 3, negative 1/3. So I'm going to put a little check mark because that one is a solution. Okay, now I have to check the other one. So I have 3 times negative 13/15 plus 5 equals 12 times negative 13/15 plus 8. Okay, I'm going to ignore that right side. I'm going to look at this left side. 3 times negative 13/15 plus 5. On the inside is 2.4. So I have the absolute value of 2.4. What's the absolute value of 2.4? How far away is 2.4 from 0? 2.4. Now I have to figure out what the right side is. So I have 12 times negative 13/15 plus 8. I get negative 2.4. Is 2.4 equal to negative 2.4?
No.
No, one's positive, one's negative. If I ask you for $5 and you take $5 from me, am I going to say that's equivalent? No. Okay, so positive can't be the same thing as a negative, so those are not equal, which tells you that x does not equal negative 13/15. Okay, this is an extraneous solution. Extraneous solution means it's not a solution. So on a quiz, I would write a line that has a solution, and I would write a line that says extraneous solution. Can I write x equals negative 13/15 on a solution? As a solution? No, because it's extraneous. It can't go on both. It has to be one or the other. It's like the rational and irrational. They're disjoint sets. Either it's a solution or it's not a solution, but it can't be both. So this one would fall under a solution. This would be extraneous because x does not equal negative 13/15. That's how I would write my answer. It's just like this if it was on a quiz. And that's how you should write your answers on your assignment too, so you get in the habit of which one's extraneous and which one is a solution. Okay? You never have anything on both. It was a lot of work, but that's why we want to make sure we identify which ones could be extraneous so you don't have to do all this work on every single one. So if you turn it over, we just have 2 more examples left. All right, so we have these last 2 problems here. Now, could we have an extraneous solution in this problem? We could, because there's an x on the outside. Okay, could we have an extraneous solution on this one? Yep, because there's an x on the outside. Now I want to flip back to the examples from the previous page. See how this one, remember we said we got to that it was equal to a negative and we said there was no solution? Okay, if we would have kept solving, you would have had 2 solutions here, but when you plug them back in, they're both extraneous. Now the problem with that is you'd have to recognize it from here because looking at your original, since there's not an x on the outside, you would not assume there are extraneous solutions. Does that make sense? So you have to make sure that you identify that when you have the absolute value equal to the negative, you have to recognize that as no solution. Go ahead. Okay, so these 2 examples here. The absolute value bars are alone, so we go ahead and we break it up. The left side stays the same. The right side, one of them stays the original. And one of them, it's going to be the opposite. So what's the opposite of x plus 4? Negative x minus 4. You negate both terms, or you make the opposite of both terms. We solve both of these. So x equals -1 or x equals -3. Okay. Now we have to plug them back in because there's a chance we have extraneous solutions here. So when we plug them back in, I have 2 times -1 plus 5. The absolute value of that is equal to -1 plus 4. The left side, simplify it. We have -2 plus 5. -2 plus 5 is 3. And the absolute value of 3 is still 3. On the right side, -1 plus 4, well, that's also 3. So what does that tell us from what we've done?
We got it right.
Okay, we got it right, but what do you mean?
3 is 3.
What did we plug in? What did we plug in for x? -1. So that tells us that x can be -1, that is a solution. So I'm going to put a little check mark here because I know that is a solution. Now I'm going to try the same thing but with the -3. Cover up the right side. I have -6 plus 5, which is -1. -1 is 1 away from 0. Now I look to the right side, -3 plus 4, that's 1. 1 is equal to 1. Cool, that means I plugged in -3 and that's also a solution. So both of those are solutions. Just because there could be an extraneous solution does not mean there has to be an extraneous solution. So this is a solution, and this is a solution. They're both solutions in this case. And I don't have any extraneous. So on my quiz, when it would have my solution line and my extraneous solution line, I would write x equals -1 or x equals -3, and I would write none on the extraneous solution because I didn't find any that were extraneous. Both of those worked, both of them were solutions. Okay. Since we already had one example with an extraneous and one without, I am not going to do that last example. Instead, you're going to have the rest of the 20 minutes to work on your assignment.